4 points just for this. That's the same as 4 multiple choice questions. And you need to remember that. Every single word counts. Why? Because this part right here is worth 4 multiple choice questions. If you had everything you needed. 4 points. That's a lot. Do you know what I'm saying, Sandy? So make sure you have everything there. So again, at this point you got 1 point for the 2 answers. Plus or minus. 1 point for the analysis. The analysis would be something like the negatives and positives and stating that now instead of just the sign chart. And the conclusions, you probably got 1 for each. 1 point for this conclusion min, 1 point for this conclusion min. And if you notice here, it looks like they're taking a point away for not saying anything about x equals 0, or like not dealing with it anywhere. Okay? So just kind of keep that in mind. Make sure you add it somewhere, you talk about it, something. Because critical points are where the the derivative equals 0 and undefined. Alright, so that's A. Any questions on that? And that's how it's scored. B. And again, score yourself. That's what I want you to do when you're going along. How many points did you get? And you got to be hard on yourself now. You know what I'm saying? B. So your justification shouldn't just be this, your analysis. It should be those words. If not, you didn't get the point. Because they're trained not to even look at this anymore. B. On what intervals, if any, is the graph concave up? What are we thinking concave up? Johnny?
Second derivative.
Is? Yeah, so second derivative, so how do I figure that from what I have? Take the derivative of the derivative, and that'll give you the second derivative. But we don't eat in class because that would be weird. So when you do that, again, 2 different ways. Who set up quotient rule? Who did quotient rule? Great. Quotient rule is fine. You can also do, again, if you have x squared minus 2 over x, you can split this up. You can split the numerator up. Did I write that right? If you want. I don't know. It's still kind of, might not be easier or not. But then this becomes, does that make sense, you guys? Same face, add your numerators. You can't do it the other way, but you can split up your numerators. If you have the same base, you add them together, you'll get here. So this function is the same as x minus 2 over x. And then you could have taken the derivative with that. Whatever you choose. In either case, you get something like this. 1 plus 2 over x squared. Did anyone get x squared plus 2 over x squared?
Yes. Yeah.
Also correct. Because you take this, multiply it by x squared over x squared, and you add your numerators. Does that make sense? And what the graders will have to do is make a little list of any form and have it all listed out. You could have also said pi over pi plus 2 over x squared. Why? Just to be annoying to them, but it's correct. Do you know what I'm saying? And they have to accept it. As long as it's the correct form, you're all good. So then, okay, when do I know that when this thing is positive? How can I figure that out? What did you guys do? David?
Wasn't it always positive? Maybe you have like x squared where there can be any negative number?
Yeah, like this is never with a plus here too. So it's not a minus, it'd be a little place where it'd be negative. But yeah, this is a plus. So this is positive numbers divided by, this is all positive. And the only critical, whatever it's inflection point possibly would be when the denominator equals 0. But since it's all positive, that's not even an inflection point because it goes positive to positive. So yeah, so somehow in your analysis you figure that out. Like how do you know when this thing is positive or negative? And make sure, are you using your calculator or not? Well, what section of the test is it? Don't cheat. Okay, Joanna? Alright. So in this case, check this out, you guys. You got 1 point just for taking the second derivative. Just for knowing that. That's one whole multiple choice question. You know what I'm saying? It's a lot of points. You got 1 point for just knowing, just writing this and understanding that. Concave up, second derivative positive, and then 1 point just for the answer. So 2 of the 3 points isn't even finding, it's just knowing this. So when I say, Wayman, even if you have no idea how to solve a problem, put some calculus down on the sheet of paper. Why? Because you earn points for every step along the way. Do you know what I'm saying? If you see concave up, even if you're it's like gobbledygook equation like Goofy Town, and you don't know how to take the derivative of it, at least show that you understand some parts, like you would know what to do once you got the second derivative. You know what I'm saying? Instead of writing, why so serious? This I did 2 years ago. What other question?
About the scoring test for the free response, so you don't get points off for it being
No.
you just don't get that.
You just get points, yeah. And this year you don't get any points off on the multiple choice either. They're changing that this year on all the APs. You don't get points wrong. What's that?
I said we're lucky.
Well, luck, it's just, I mean, it's a scaled score, so I told my guys, I was talking to Mr. Bywater about it, just probability-wise, if there's 5 choices, you know, like it is on the AP test, well, probability speaking, if you guess on 5, you're going to miss 4 and get 1 right, and you lose a quarter point on each one that you miss, so it's a wash. You know what I'm saying? So I always say might as well guess anyways, you know? You might have a good guessing day. But that doesn't even matter anymore. Does that make sense? But everyone had their own personal feelings on that whole idea. Do you know what I'm saying? Does that make sense? Okay. Alright, so then on what? The equation for the tangent line. Any problems with that? Great. Just 1 point. Well, at least it's something. And then, does the tangent line to the graph lie above or below the graph? And why? And does that make sense now?
Yes.
The second derivative is positive, always. So, it's an under approximation. Or the tangent line lies below the graph. Okay, cool? How do we feel with that one, guys? What does that mean? Beep boop. All right, that sounded good. So just A and B. Yeah, so if you guys look at D, we're going to get to this. But what we need to do with D is, for you calculus guys, this is how you write. Final position equals initial position plus displacement. Have you guys heard of that before? Physics people, especially in AP, you do that a lot. This is the calculus way to write that. Final position equals initial plus, but we're going to get to that in 6. Okay? That'll be fun. Alright, so you're given what in this problem? You're given a velocity, and they want, the first question, acceleration. How do you get that? Take the derivative. Bam! And then just like this, there's 3 correct different answers you can do. Negative pi over 6. Or, this is the same as negative 0.5235 and 9, I think it was. So you can either truncate, meaning cut it off after 3, or round. And that's why there's these 2 answers. Okay? Both would be valid. So, do we have time to talk about these? No, we have that. So how do I know when a velocity is decreasing? Yeah, like increasing, decreasing, that's derivative stuff. So when you want to know velocity decreasing, one way to say it is the graph goes down. Well, that's not a very calculus way to say it. What you would say is its derivative, which is acceleration, is negative. Then the velocity is decreasing. Does that make sense? Now as far as speed, when is something speeding up in general? Yeah, either when speed is increasing when you're going away from the x-axis, in either way, or when the velocity and acceleration are the same sign. Does that make sense? When velocity and acceleration are the same sign, you're speeding up. When they're different signs, you're slowing down.